When you come to class tomorrow, you're going to work in pairs, creating worksheets to review the transformations of trig functions that we've been studying. Today in this podcast, I want to show you how you can use Geogebra, first of all, to create the images that you'll use in those worksheets, as well as show you how you can use Geogebra to actually review and practice those worksheets or those transformations before class. Before we use Geogebra here, we need to make a quick change in the graph itself. You notice the x-axis is in just simple numbers, and we want to change that to radians. It's more conducive to working with trig functions. So in Geogebra, if you go up to the options menu at the top of the page, you'll see something called settings. If you click over on the graphics tab and then go to the x-axis, you'll see the units can be changed to pi. Once you change those units to pi, save the settings and then close this, and you'll notice now your graph and the x-axis is marked off in units of pi, and we're ready to begin. Now, to create an image that you're going to export into your worksheet, it's a fairly simple and straightforward process. You just come down here to the input box, and I'm just going to type in here y equals sine x. I now have a trig function that is ready to export. If I go up here to the File menu, I come to the Export option, and you'll see Export Graphics View as a picture. Click on that. I'd recommend just using the PNG format, so you want to save that. And what I'm going to do is I'm going to save that to my desktop, and I have created a folder there called Trig Functions, and maybe you just want to call this Problem 1. And .png, and then just go ahead and save that. Now what you've done is you've saved that file, which you can then export into a Word document or a Pages document to create your worksheet. Now maybe you want to do a different function. The easiest thing to do is just come up here and double click. I said that. Double click on this. Let's go down here and double click here. There you go. Okay, we double click on that function, and we can just simply change this. Maybe we want to change this to 2 times sine x. And we say apply, and you'll notice it changes that function. And now I've got another one I can change. So I can come back up here to the File menu, and I'm going to export it as a picture. And it's going to be the same kind of picture. And this time I'm going to call it Problem 2. It's still going to be going into the desktop folder. And go down here to the trig functions, and now I've created a second image. Okay, so it's a very simple process to do that. Now, what we're going to do is we're going to, and so you'll create 5 or 6 of these images, put them into your worksheet, and then use that to create the review worksheet that you'll be exchanging with other students in the class. The remainder of the time I want to show you how with a powerful function within Geogebra, which will allow you to actually review some of these transformations. So the first thing I'm going to do is right click on this and delete this particular function. And we're going to go ahead and create the parent function for sine x. So I'm going to type in down here y equal sine x. Okay, and that did not, oh, I mistyped that, I'm sorry. Let's delete that. And let's try again. Y equal sine, works better this way, sine x. Okay, and you'll see it creates the parent function for sine x. Now for just a minute here, I want to, let's say we change the color of this temporarily. Let's go to Objects, and we're going to change this color to a bright red so that it stands out. And we'll go ahead and apply that, and we're good to go. All right. So you can see there's the parent function y equals sine x. Now what we want to do is explore a little bit how we can use Geogebra to transform that particular function. Now to do this, I'm going to, first of all, I'm going to hide this object. I'm not going to delete it. I'm just going to click on it and hide that object here for a moment. And we're going to use a powerful feature of Geogebra, this thing called sliders up here. If you click on this arrow, you'll see it gives you the option of creating a slider. And what we're going to do is we're going to create 4 sliders to represent the 4 different transformations we can do to a trig function. We can translate it on the x-axis, which is called a period transformation. We can translate it on the y-axis. We can also transform it by changing its amplitude and frequency. So we're going to create a slider here. And this slider, actually, we're going to click on this little symbol over here on the right-hand side, which is going to allow us to actually create something other than a numeric value. We're going to use an angle value here. So we're going to change this to an angle. We're going to have it go from 0 to 360 degrees, but instead of increments of 1 degree, let's make it 15 degrees. Okay? And so we've created a slider which we will be able to move back and forth, changing its angle by various number of degrees. Okay? Now, we're also going to create a slider. We're going to create another slider here. And this one is going to be, we'll just call it A. It's a numeric value. Let's go ahead and just apply it as it is there. We'll go ahead and create another one that we're going to call B. And we'll create a third one that we're going to just leave it as C. Now, what we're going to do is we're going to come down here to our input box and we're going to create a function. It's going to look like this. It's going to say y equal A times sine of, and then we're going to go B times x minus, and then we're going to put the alpha in there. And then we're going to add c to that. Okay, what we've created now is a function which has a number of variables in it. And these variables can be controlled by these sliders over here. Now you notice this thing is a little bit high. Well, that's because the c, which is being controlled right here, this is controlling the y-axis, the c has set at 1. If we move that back to 0, okay, we'll see that we've moved this thing now back to the place where it should be, and now we're looking at y equals sine x. Okay? If we want to change the amplitude of this function, we can change that by simply adjusting this value, which you can see changes the amplitude. Now, here's something that's kind of fun to do, because remember our parent function that we hid a moment ago? Well, we can turn that back on, and we can see how this function now compares to that original parent function. And so if we want to change the amplitude back down to 1, we just simply slide this thing back down, and we're going to find these things are right on top of it. Now, if we want to change its frequency, you remember that was the part where we said the b was times sine x, or sine of bx, and so if we change this b, you're going to see that that in turn changes the frequency. And so if we have 2, notice here that sine is making two complete revolutions on our black graph in the time that it makes 1 complete revolution on the red graph. Well, that's given by this 2 at the beginning of the function. Okay, so once again we can change the amplitude as well. We can do multiple transformations here. Now it has an amplitude of 3 to -3. By the way, what do you think would happen if the amplitude became negative? Well, we can check that real quickly here. Now we bring it back down here to 1, okay, which is our parent function amplitude. Of course, if it has no amplitude, it becomes just a vertical line, and now you'll know, or a horizontal line. Now you notice what we're doing is we're actually turning it upside down, okay, and so it has actually reversed its course, and now we have the same thing, but now it has, the amplitude is now the reverse of where it ought to be. So now we've got it up here at 3, and again, you can see how this compares to our parent function. The other slider that we really haven't talked about yet is this one here, which for some reason does not appear to be working. We have to work on that a little bit. Why is that slider not working the way we want it to? Let's see if we can figure out what's going on here with this slider. It is fixed in 15 increments. Let's give it increments of 15. Close that. Cancel that. Cancel that. And now let's see if we get the slide. There we go. Okay. Now we've got this slider. You'll notice that by moving this slider, I'm now able to translate this thing sideways in a period function. Now let's put it back to its original form. Okay, let's get it back down to the original value where its amplitude was 1, where the frequency was 1, so it's back to where it's supposed to be. Okay, and so now it's right back to the parent function. You notice as we move this slider, we're moving it out of phase here a little bit. Okay, we're just changing the phase. And of course, now we're 180 degrees out of phase. Okay, of course, if we went to 360 degrees out of phase, we would be right back where we started, and it would once again be right on top of the original function. And so we can adjust the phase by simply moving this thing back and forth. So you can play with these different values. The slider is a very powerful feature, and you can very easily see what the effect is of various different transformations on these trig functions. I'd encourage you to spend a little time playing with this, getting acquainted with it, and then tomorrow when you come to class, we'll have a quiz to start the class to make sure that you understand these transformations, and then you're going to be working on these worksheets in class. So look forward to seeing you tomorrow.